Hello, everybody. Welcome to the webinar on frictionless security, how to add silent auth and to your iOS application. My name is Abdul. I'm a senior developer advocate here at Vonage. But yeah, let's just hop straight into it. So today we'll be going over authentication. So a bit of background on that, the Vonage Verify API, silent authentication, and how to add silent authentication to your iOS application. So before we begin, I guess it will be a good idea to define some terms. So first up is authentication, which is something you might have heard thrown around a lot. So authentication is verifying who a user is. So for example, if you have an app and you want to gate some sort of features behind a user, for example, having Instagram where a user can post images, you want to make sure the person who's logging into the account is, say, Alice. And once Alice logs in, Alice can post pictures and videos to Alice's feed, right? But you've also maybe you've heard the term authorization thrown around. So, and you might be wondering what the difference between authentication and authorization is. So authorization is determining what a user can do. So this is a slight difference from authentication when we're just verifying who a user is. It's good to define those terms ahead of time because it helps you think about where the Vonage Verify API can fit into your applications. So the Vonage Verify API helps you authenticate who users are. And that authentication depends on which channel you're using, but realistically, most authentication checks whether a user is tied to the phone number that they say they own. So with the Vonage Verify API, we are verifying who a user is. So the Vonage Verify API helps you verify who a user is by enabling you to add two-factor authentication to your application. If you're not familiar with what two-factor authentication is, it is adding a second layer of security to your application on top of anything you may have already. So for example, if you have login with email and password, that will be your first factor. Then your second factor, so the password, sorry, will be the first factor of authentication. So that's something the user should only know. Then the second factor, so in the two-factor authentication, in our case, will be a phone number. So this is also so the user should be the only person knowing their password. And in case that fails, the user should be the only person with access to their phone number. You might have seen two-factor authentication as a OTP code, which is sent to you via an SMS. So this is when you get a very short code where you have to copy and paste it into the application. The good thing about the Vonage Verify API is that it is multi-channel. So you can authenticate your end users where they prefer. So the channels include SMS, as we discussed already, voice, email, WhatsApp, and silent authentication, which we'll talk about a bit more later. The Vonage Verify API also lets you define a workflow that works for you. For example, if you want to send an SMS first and give the user, let's say, a minute or two to respond via SMS, and if they don't respond via SMS, you can fall back to voice. And from there, you can also fall back to email. So this is the Vonage Verify API is quite flexible for what you may want to use it for. So next up in terms that we need to define is silent authentication. So you may be asking how silent authentication differs from OTP, which is sending the shortcode over a channel. So silent authentication uses a mobile phone's subscriber identity module, or SIM card, as you might have heard it called, to prove a user's identity without any user input. So the big sort of shift here is that you're doing this without any user input. and it's allows you to create a more frictionless experience versus having the user close your app and go to a browser or receive a phone call and input a number, for example. Here's a diagram of how Silent Auth works in the browser. It works very similarly for um, iOS development or Android in that case. But so yeah, so anytime you see the term browser used, imagine it's an app. We'll be referring to this diagram a few times in the webinar, but just to give you an overhead straight away. So in your app, you will make a request with a phone number. So your phone number is 1234. You make a request to your server. Your server then tells Vonage us that you would like to start a new verify request with a redirect URL. Then Vonage then returns a check URL. So this is the URL that you need to open on your Android iOS browser device. But the key thing to know here is that the check URL needs to be opened on a cellular network, not on Wi-Fi. So this is why Silent Authentication is very powerful for Android iOS, because of course most people have a cellular connection already. And Vonage also offers the Vonage client library, which has a helper function on there, which allows you to force a specific request to happen over the cellular connection in case the user is on Wi-Fi, and cellular is of course available. So we have a Vonage client library available on Android and iOS to help you do this. But yeah, we'll get back into it. So you have the check URL, which is returned to your browser, iOS, or Android app from Vonage. Then once the check URL is hit on your app over cellular, this is where Vonage runs off and does the checks with the cellular providers. Then the redirect URL is hit, or in the case of Android iOS, it will be the last call in the set of calls. You'll see this later. And on that, you have the request ID and the code. So the rest, if you're not familiar with the Vonage Verify API, the request ID is just an identifier for the specific verification request. So you get request ID regardless of which channel you're using. This allows you to, for example, cancel a request. Then the code. So this code is actually, I guess, similar to the short OTP code that the user will have to hit normally. But because with Silent Authentication, Vonage has run off and verified that this check URL was opened from the phone number specified here. So we can say Alice has given us the phone number 123. Then Vonage can confirm that the check URL was opened from the phone, which has the phone number 123. So Alice, or this request has come from Alice with the phone number 123. So with this request ID and code, you can then finish the Vonage API authentication flow, which happens similarly with the other channels at this point. And once that's done, you can verify that a user is making a request from the phone number that they said they were. So let's quickly go through a demo and code walkthrough. I will initially show you the backend code required for this. This is a session mostly focused on iOS and Android, but iOS specifically, but I will quickly go through the backend code just for reference. So yeah, as mentioned in the diagram, your mobile app will make a request to start the verification. So in my case, they're hitting the /request root. Then in here, I use the Vonage Server SDK to start a new request. And here is the workflows that we were discussing earlier. So I'm doing a silent auth workflow with the number that the app specified. And in this case, I'm just using the sandbox for testing. But we can jump into here and look at some of the other workflows as mentioned. So we have email, SMS, silent auth, which we're using, voice, I have WhatsApp interactive and WhatsApp. So you can specify, as you can see, workflow is an array. So if you wanted to, you could specify, a new channel here of voice, for example, and fill out the required parameters, and you can fall back to voice. But in this case, we're just doing sign off. So yeah, so the iOS app will hit /request, and this will generate a new verification flow on the silent auth channel. Then this responds with, if we go back to the diagram, this responds with the check URL. So that's what we're returning in this response here, is a check URL for the app to open. So once the app has opened the check URL, so here, we will receive a redirect on our redirect URL, which is something you specify ahead of time. And that will be done on the app side, and that will give them the code and the request ID. So once that's happened, the app again hits our server with the code and the request ID. Then we either get a yes or no from the Verify API at that point. So yeah, so to clarify, what you just saw on the server was this call here. So we're creating a new verify request with the redirect URL. Then the second route we looked at was checking the code. So this checks whether the code that the app receives from the redirect is correct, and that returns a yes or no here. So this arrow here is what the first route we looked at, and this arrow here and this arrow here were the second routes that we looked at. Cool. Now that that's done, we can look at the actual iOS app. So in this case, we've used a game as the example. So this is an iOS app using SwiftUI. And I guess as a general flow for the app, I'll do a demo in a second. The app asks the user to log in with their username and password, as you're already familiar with. Then on the next screen, they'll be given an opportunity to enter their phone number. Then once they enter their phone number, the silent authentication happens in the background, and they'll either be let into the app or not. So we'll just wait for the app to launch for a quick demo of the various bits. Here we go. So we're now in our Vonage game, and I can log in using my email and password. So I will just do abdul@vonage.com, and my password is something secret like this. And now if I log in, so now this is the number verification screen. I've pre-filled a test number for me to use. But once I hit verify, so this is now making the various calls that happen in the background. And hopefully, if successful, we will get through. Great. So now, as an added extra, since we are on iOS, we can also use biometrics, in this case, Face ID. So I'll just enable Face ID on this simulator. Then I can say, do you want to log in with biometrics in the future? So this way, the next time the app launches, they don't need to re-enter the username and password. So I say yes, and this should come up with a prompt because it's the first time. And I can say yes. Excuse me. Yes. Face ID. And now we're in our game. So very simple game. You want to get two balls of the same color to touch, then that gets you some points. Sweet. Nice. So this is just a simple game using SpriteKit and the inbuilt uh, physics simulations as well. Great. So let's get rid of the simulator and have a quick look at how that is built. So we go into our home view. So here we just have an enum to keep track of the different states the app can be in. So we start off in unknown here. Then once the app launches, we call, so on this on up here, we call set app state if needed. So this checks whether the biometrics has been enrolled or not. And if it has been enrolled, we check the biometrics. If it hasn't enrolled, we transition to the unregistered state, right? So this allows them to, this shows the login view, which we, fairly simple. It's just email and password. This, of course, doesn't connect to any login sort of user service because it's just a demo for this. But in your app, this will be, I assume, more complex. But assuming the login is successful, and in our case, it will always be, we transition to the verify state. So this is where we want to verify the user. We'll hop into that a bit later. And if they do verify successfully, this is at the point in which we want to offer them the opportunity to enroll with biometrics as a shortcut. And this transitions to the enroll biometric state. And in the enroll biometric state, we have the register biometrics view, which uses, I've built a very simple biometrics manager using the local authentication framework. So yeah, I guess, yeah, another point to mention is that Face ID or biometrics only, I guess, authenticates that the person who's using Face ID or Touch ID is supposed to be using that phone, for example. So it doesn't say, yeah, as you can see here, it says the device owner authentication with biometrics, right? So this says, in the case that Alice has registered her face on the phone, is the face looking at the phone Alice? That's what we're checking here. We're not checking whether Alice is authorized in the app or anything like that. We're just very simply saying, is the face looking at the phone authenticated to use the phone, right? So that's why we wanted to. That's why I've gated using biometrics after doing the verify, because we want to add. We don't want to. We don't want to make it easier for someone who's not supposed to be in the app to log in, right? Then yeah, as mentioned earlier, if they've already enrolled biometrics, we check the biometrics. And in the case of enrolling initially or a successful enroll, it goes to the game. And if that fails, it goes to the unregistered state. Then we also have a settings view, which allows you to delete the account, which we'll go into later. So just to demonstrate the Face ID login, so if I relaunch the game, I should be presented with the Face ID screen now, where I can say, yes, I am the correct person, and jump straight into the game, right? So this has saved me entering my email and password again, right? But yeah, if I was to run that again, but this time I failed the Face ID, it takes me back to the login screen where I have to enter my email and password to make sure I'm allowed to use the app, right? Cool. And that's everything that's needed to be known on the home view. But yeah, the home view is mainly just to manage the different states of the app. But I guess the state that the view and state we're most interested in is the verify view. So this encapsulates all the different verify calls. Just to bring that up, this is the verify view here. So we have a text field and we have a button that calls the verify user function, right? So in the verify user function, I guess just to map the different requests happening here to the diagram. So we have the verify request. So yeah, we have do verify request, which is this arrow here, request for auth with phone number. So we send our phone number from the app, browser, Android, iOS app to the server. The server starts the new verify request, which is the first route that we looked at. Here. So we start the new verification request. Then that either returns or doesn't return, but assuming it returns, we get the request ID and the check URL. But realistically, we only need the check URL at this point, but this allows us to initiate a cancel from the client side. So once we have the request, the check URL, sorry, we can do the silent auth request, which is something I'll talk about later. But this is this arrow here, so check URL hit. Then once the silent auth request goes through its various redirects, we should get the I believe the code. Yep. So we get the request ID and the code. So this is then once we have the request ID and the code, we can do the verify check request. So here, so this browser to server with code, but in our case, app to server with code, which is what we're doing in do verify check request, which in turn calls this route, which is check code with our request ID and code, and this returns the status here. Then we say if the status is completed, our verify attempt is true, and if not, that should be false. There you go. So if our verify attempt fails, then this should be false. Then if we have any errors, show the errors as well. Cool. Then I guess just to walk through the various API calls, I just have a server here, which is just a deployed version of the code I was showing you here. So we go into do verify request. So we use our base URL and we go to slash request with the post request of application JSON. And in this case, we're just sending the phone number. So this is this phone number here ending 066. We send that to the backend. Then if that all goes well, we should get a verify request response, which has a request ID and check URL. Then I guess uh, the new part is to do the silent auth request. So this is the request that needs to happen over cellular, which is why we're using the VG Cellular Request Client, which comes as part of the Vonage Client library. So the Vonage Client library is open source and available on GitHub. Currently, it's a library to support any things that you need to do on iOS to work with the Vonage APIs. Currently, the only function or client available is to force a network request for use with Vonage number verification or Vonage Verify Silent Authentication, which is the one we're doing today. I've installed it using Swift Package Manager. So if you're not familiar with how to install it with Swift Package Manager, if you click on your app here, project, then under package dependencies, you can add a new package dependency. And you can paste in the GitHub URL there. But I've got mine already, and you can choose the range of versions that you want to use. Then, as you can see, it's been downloaded and added to my project here. The Vonage client library is also available via CocoaPods as well, if that's your preferred package manager. Or if you want, you can just come into the source here. It's all open source. So you can just copy and paste this into your project if you prefer. The Vonage client library is also available on Android as well. There you go. So yeah, everything I say here should map one-to-one if you're doing this on Android as well. Cool. But yep, just to doubly confirm, what we're looking at here is this arrow here, the check URL hit arrow is what we're looking at. So if I come back into my verify view, I've created a new client. This is the VG Cellular Request Client as defined here. And once then to make a to make a cellular request, you need to provide some parameters. In this case, we provide the verify request response check URL that we got from initiating our verify request. Then you have the option to provide any headers. For example, I mean, my server is quite simple at the moment, so there's no authentication, but you can imagine or you might need to provide some authorization headers, etc. Then you can also provide query parameters. So you can say, user is outdoor at vonage.com. So this lets you pass any context you want from the backend. I guess both depends on your preference, but yes, the header and query parameters allows you to pass any context you want from the client to the backend once the check URL flow has completed. But yeah, if you're interested in, I guess, what happens behind the scenes. So I guess this sort of space here, you can refer to the Vonage Verify API Silent Authentication documentation to where it discusses a bit about how this works with the cellular providers. Then you can also specify a matched redirect account. I guess just as a aside, like part of the check URL flow is to redirect you to um, the correct cellular provider for the number and redirect you back. So sometimes this might go above the default of 10, so you can change this here as well. So yeah, so once you've set up your parameters, you can start the cellular GET request. So this performs a GET request to the check URL. Then once that has done its various redirects and it's returned back to your client here, you can say, you could grab the body from the response and yeah, do a JSON decode like we were doing earlier. And in this case, we will get the verify code response, which will have the request ID and the code. Then, and as mentioned earlier, this is very similar to the initial request that we're doing here, but instead we're hitting /check and we're sending the request ID and the code. And this will respond with a status, which will say whether it's been completed or not. So yeah, that's sort of the bulk of it. Yeah, then I think we can do a request quickly just to look at the logs. So as you can see, we're hitting various endpoints here and getting various 302s, so 300 HTTP status is a redirect. In this case, we're hitting the sandbox. We eventually land back at Vonage. Then eventually we start getting a 300 and we get a 200 OK. So we're done. Then, as mentioned earlier, this has our request ID and the code, right? Then this is the code we send back to our server. So this code here, and this is the one that gets sent to Vonage. So I'll restart the simulator there one last time. The thing to know if you're having any issues is that the start cellular get request function call also has a debug parameter. So if you're having issues, you can set debug to true, and you'll get more verbose logs about what's going on. I'm just logging back into the app now. So Vonage.com, my password, verifying. Cool. So I'm back in the game. Happy days. So you might have noticed there's a settings cog here at the top. I've just added this to mimic any settings or any privileged actions you may have in your app. So in this case, it shows me the account and allows me to delete my account, right? Because deleting an account is such a very heavy decision or privileged decision to make. What I've done is I've added verify here again. So I'm saying before you delete your account, you need to verify whether you're the correct person, right? So the number tied to this request that we're making. That doesn't seem to have worked this time. Not sure why. But let's restart that. So, sorry. So back in, delete my account, delete, verify. There we go. So now this is all, kicked me out of the game, delete my account, but that's required, again, another level of authentication. So you can imagine in your game, for example, if someone wanted to buy some credits or to transfer their account or basically anything that's privileged, you can again add number verification to ensure they're who they say they are. But I'll create a new account here. And log in. So another feature of the sandbox, so if you remember, we're using the verify sandbox here, is that if your test number here, so this is just a random number which conforms to the UK standard. If your test number ends in even number, your verify request should pass, and if it ends in the odd number, it should fail. So hopefully this fails. Correct. There you go. So in this case, we've got a device MSIDN, so that's the phone number doesn't match. So this is a sample error you can get, and this just has linked it to the developer docs. So I believe that will probably have failed at this point because we're not able to decode this response, right? Or maybe, excuse me, yeah. But yeah, you can follow this link through. It should hopefully take us to the error. But yeah, that's just a good way to test out the different flows using the sandbox. You can just do an odd number for failure and an even number for a pass. Cool. So that's just about everything when it comes to the app. But just for clarity's sake, we can do a quick, I guess, side-by-side run through, hopefully, of the different bits going on with the verify. So yeah, so initially, we do the verify request. So this sends a post request to this endpoint here / request. So this kicks off a new verify request with a workflow containing the silent auth channel. Once that returns, we do the silent authentication request. This happens without the server. So once the check URL has been returned, we hit the check URL and that returns back to the app. So the server is not privy here. But once that does return, we do the do verify check request. So that's this request here where we give it the request ID and the code. And that's where we can say whether this is a true or false from the Vonage Verify API standard view point of view. Then we return this response back to the client, and we can say if completed, great; if not, false. We're also available on various platforms, so you can visit our website, which is developer@vonage.com. The Slack is mentioned. We're on X or Twitter, YouTube. We have a blog, LinkedIn, or as well, if you have any questions, you can email community@vonage.com. And thank you.